Hello and welcome back to the AI Research Roundup. I'm your host, Alex, and today is June 13th, 2025. Alright, so today we're looking at a paper from Hugging Face's trending list, published just over a week ago, called Confidence is All You Need, Few-Shot RL Fine-Tuning of Language Models. This paper introduces a really clever method called reinforcement learning via self-confidence, or RLSC. Essentially, instead of relying on costly human feedback, this approach uses the model's own confidence in its answers as a reward signal. It's a form of few-shot fine-tuning, which means adjusting the model with just a handful of examples. The results are quite striking, showing big accuracy gains on math problems with very minimal training. So this first figure really visualizes how this reinforcement learning via self-confidence approach works. The top diagram shows the workflow. A question is fed to the LLM, which generates answers. Then, the system estimates the probability for each of those answers. The model's own confidence is then used to calculate a loss, which is a penalty signal used for learning, and that signal is fed back to tune the model. The bottom part shows the result. Before training, the model's probability distribution is spread out, showing uncertainty. After, it becomes sharply peaked, indicating high confidence in one answer. Building on that idea of the loss signal, this next table gets into the mathematical details. It compares different types of loss functions, which, again, are those penalty signals for learning, and the functionals, which are the mathematical objectives the model tries to optimize. The first row shows a loss function for reinforcement learning from human feedback, or RLHF, a common method using human ratings. The new approach is a version of this, but it ingeniously uses the model's own past confidence as the reward, instead of human input. Moving to the results, this table really shows the payoff. It compares the baseline QN 2.5 math models, both the 1.5 billion and 7 billion parameter versions, against the same models after applying this new reinforcement learning via self-confidence tuning. And the results are quite dramatic. Across a whole suite of tough math benchmarks like Math 500 and Olympiad Bench, we're seeing accuracy jump by over 20%. This really validates that using the model's own confidence as a reward signal is a powerful and incredibly efficient way to improve its reasoning abilities. To give you a more concrete feel for what this means in practice, this table shows a direct comparison of the model's output on a specific math problem. The problem asks for the distance between 2 points. Before the tuning, the base model just spits out an incorrect answer, 10, with no explanation at all. But after applying reinforcement learning via self-confidence, the model provides a full step-by-step solution. It shows the formula, the calculation, and even provides Python code to verify its correct answer. This really demonstrates the tuning improves not just accuracy, but the quality and confidence of the reasoning itself. And here's another fantastic example of that improved reasoning on an Amy-style game theory problem. The tuned QN 2.5 math model is asked to find the number of winning positions in a game. Instead of just an answer, it provides a full solution. It defines the winning and losing states, formulates a function to model the game, and then it actually writes Python code to compute the result. This ability to construct a logical and computational solution shows a huge leap in the model's problem-solving capabilities, far beyond simple pattern matching. So what this all comes down to is a really elegant idea. This method, reinforcement learning via self-confidence, shows that you don't always need expensive human feedback or complex external reward models. By simply training the model to be more confident in its own best answers, it achieves these dramatic accuracy boosts on tough math benchmarks. It's a simple, scalable, and highly efficient way to improve a model's reasoning, unlocking potential that was already there. Well, that's all for this edition of the AI Research Roundup. Thanks for listening.